Okay. Let's start it already. Be quiet. Okay, so yesterday we learned about permutations and also whenever we pick a subset from a bigger list of elements. So the permutations were stuff like, let's say I have a list of 10 elements, for example. Let's say I have a list of 10 things, and I want to see how many different ways can I order those 10 things. And so we got a number based on the number of elements that we had to get the number of orderings. Who remembers what that number is? How do we calculate the number of permutations given a list of 10 elements? Factorial. Right, so if it's a list of 10 elements, it would be 10 factorial. I'm recording, so the more noise you do, the more noise comes up in the video. So please stop making noise. Okay, so if I have 10 elements, the number of permutations is 10 factorial. Now, the second version of this type of question would be, what if I don't want to pick all of my elements? What if I only want to pick a subset of them? If I have 10 elements, but I only want to pick 4 elements, that equation is expressed with this notation. So the bigger number on the left will be your total number of elements, and then you write P, and then the smaller number is the ones that you actually want to choose. And so the equation for that, permutations of n objects taken r at a time. So n and r can be any number. This expression would be equal to this equation basically. And so the equation tells us, let's say I want to pick 3 elements. And the question is, how many different ways can I pick 3 elements out of these 10 elements? You use this equation, so that would give you 10p3, and 10p3 is equal to 10 factorial divided by 10 minus 3 factorial, which is equal to 10 factorial divided by 7 factorial, which is equal to what? 720. So there's 720 different ways that I can pick 3 elements out of these 10.
En el examen nos va a poner como un problema que no tengamos que hacer, vamos a tener que hacerlo de esa forma, ¿no?
¿Cuál forma?
De la derecha. Si nos sale la calculadora, pues una.
You can use your calculator, so whatever way you want to do it, you can do it. The other way that this is equivalent to that other way, but the other way of looking at it is using the fundamental counting theorem, where we said, okay, we're going to pick 3 elements, so we have 3 boxes. How many options do we have for element number 1? 10. What about number 2? 9 and 8, right? Another way of saying, these two are exactly the same, and I can prove it to you. 10 factorial, what is 10 factorial? If I write it out. 10 times 9, right? Like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Right? That's 10 factorial. What is 7 factorial?
7 times 8 times 6 times
10 times 6 times 5 times 4 times 3 times 2. Right? So I have a bunch of multiplications on the top and a bunch of multiplications on the bottom. If I have the same number on the top and on the bottom, I can cancel it out, right? Cancel, 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 cancel. 10 times 9 times 8. 10 times 9 times 8. It's the same thing, but this formula makes you not have to like do this out. Because this one you would have to multiply 10 times 9 times 8 in your calculator. Here you do 10 factorial divided by 7 factorial. This is easy, right? Like this is an easy multiplication, so either way that you do it, it doesn't matter. But if I ask you 32 pick 14, you would have to multiply 14 different numbers. You would have to multiply 32 times 31 times 30 times 29 times 28, all the way down until you're done. I think it's like 19 or 18 or something. Instead of having to do that, you can use this equation, and in that case, you would just do 32 factorial divided by 32 minus 14 and 18 factorial and you just put that into your calculator, and it's much shorter to write out in your calculator than now remember.
Can you simplify?
Not really. You could. This would be simplifying, but there's not another way to simplify. The other alternative is that your calculator has a button that says NER, right? It looks like this. You should have to press shift or something. It's not like a main button, it's a secondary button. But if you do, in this example, you just literally write 10 and then press this button and then 3, it would give you this basically, and it would give you 720. So if you have a calculator and you find this button, try it out because it's going to be helpful on your quiz, not tomorrow. Tomorrow is only chapter 8.
¿Cuándo empieza?
It's on Google Classroom.
Okay.
Okay. Everybody understands the difference between permuting just this and then picking 3, right? Or picking a subset of them.
Pues ahí está más fácil hacer el de pick 3, ¿no?
Huh?
Ahí tuviera más fácil hacer 9 por 8, 10 por 9 por 8.
Whatever's easier, it's going to depend. It's going to be the same answer. Whatever makes the most sense to you, do it that way. Okay, so that's the equation. We've done that. This is where we finished off yesterday, I think. Okay, so we're going to throw a new wrench into this problem where so far every single element in your list has been distinguishable. All of them have been different, right? So far. We've had NFL teams, we've had like people, we've had letters, we've had numbers, like they're all distinguishable from each other. But there are some cases where some of your elements in your list are indistinguishable from each other. And so for example, I'm going to basically do this thing but with another example. Let's say I have a list of 3 elements, and the elements are shapes. Let's say I have a circle, I have a triangle, and I have another circle. Let's say this is my my list of elements, and these 2 circles are completely identical. They're both just black circles, right? Now, if I want to go through the permutations, I would have to list out all of the different permutations. And before I teach you this, what would be the number of permutations if I have 3 objects? 3 factorial. Remember, the number of permutations is the number of elements factorial. But there's an issue here. Now, imagine that these were distinguishable. This is circle 1 and this is circle 2. If I switch these around, 2 and 1, these 2 are different, right? Because I have circle 1 first and then circle 2, and this is circle 2 first and then circle 1. These are 2 different orderings. We agree there, right?
Yes.
But the issue comes when they're not distinguishable. These 2 orderings that were different before, now they're the same. Right? This is the same thing now, because these 2 circles are exactly alike. And so we're going to get less permutations because some of these elements are indistinguishable from each other. Does that make sense to everybody?
Yes.
So some of our elements are the same, so before, things that were different because I could distinguish between the 2 circles, now they're exactly the same, and I don't want to count them twice, they're the same thing. Something similar you can think about is like whenever you're playing dice, you usually have 2 dice. And those 2 dice are indistinguishable from each other. Like a 6-1 is exactly the same thing as a 1-6, because you don't know which dice is which, right? And so that's kind of the idea behind this. Now, if we have permutations with repetitions, we can consider this, let's say our list, our collection of elements are E, E, and Y, but they're all colored differently. Now in this case, things work just as before because my E's are different. I have a red E and I have a green E, right? So yes.
Mister, is this different from the example of ABC, like ABC, CBA?
This will not be different because A, B, and C are all distinguishable, and this part, they're all distinguishable as well because they're different colors. I do have 2 E's, but I have a red E and I have a green E, so those are different. I can tell them apart. Does that make sense?
Yes.
So this is the same. So far, this is the same as the ABC because they're all different. I have a red E, I have a green E, and I have a blue Y.
Al final no tienen los mismos, pues.
No, 1 second. Look, 6.
Es que sí, ese, pero. Ah, sí, son tres.
Okay, so here I have 6 different combinations that I can arrange my 3 elements. Because this I, E, Y, and this I, E, Y, they're different, right? I have a red E first here, and I have a green E first here. So they're 2 different combinations. However, imagine that these letters, the E, and Y, they're all black. Right? This I and this I would be exactly the same. They're not different permutations, they're the same permutation if they're indistinguishable from each other. So if they are interchangeable or indistinguishable from each other, then in reality the number of permutations would be EEY, EYE, and YEE, and that's all I have. And so my answer would be 3. Does that make sense?
Yeah.
Now, obviously, for these small collections, like just 3 elements, it's really easy, you can just write them out. But the problem again comes whenever you have huge collections, you can't just do this and try to find all of the equal ones and start canceling them out to do this, right? And so we'll get a new equation to calculate whenever we have that problem. So this is very similar to our original equation of just n factorial, right? Our original equation would just said whatever the size of the collection was, n, like if it was 10, if it was 15, you would just do 10 factorial or 15 factorial or whatever. That part stays the same. That's the numerator. That's going to stay the same. However, what you have to do is you have to divide by a bunch of numbers. And what these numbers are the number of times that each of the letters are repeated. So for example, in the previous case, my E was repeated twice, right? I had E, and Y. So if you have multiple elements that are repeated multiple times, those would be all of your S1, S2, S3, S4, and you would do S1 factorial times S2 factorial, and so on and so forth.
Los 3 puntitos son que son S3, S4 y así.
Yeah, it's just like continued in that way until SK. And so the number of distinguishable permutations of n objects, remember, this is the total collection, where one object is repeated S1 times, and another object is repeated S2 times, and so on, would be this. You just divide by the factorial of however many times it's repeated. I'll show you an example just so it's clear. But this is your basic equation that you want whenever you have repeated elements.
So S1 y el S1 el S1 y el S2 no tienen nada que ver los números el 1 y el 2, ¿verdad?
No, it's just so that they can use the same variable.
So S1 is
S1,
1,
S2, S3, but whenever you see this kind of subset, they don't want to use like
S1
SK
is Y.
SK es como que ya el que
No,
sea.
pero S1 in that case
Los tres
is
serían
It would be S1 would be equal to 2 because I have 2 copies of E. So it would be 2 factorial.
Okay.
Yeah. So in this case, n is equal to 3 because I have 3 elements.
so you don't have to put the Y on the denominator.
What y?
The Y
Oh,
next to E. No.
you don't have to because how many times is y repeated? Once, and it would be 1 factorial, which is the same thing as dividing by 1. It doesn't.
Yes.
You could in theory, but you don't have to do it. It doesn't do anything.
Entonces serían 3 dividido
So
entre
this
dos
would be 3 factorial divided by S1 is the number of times where one object is repeated. My object E is repeated 2 times, so I would do 2 factorial. And so this is equal to, what's 3 factorial?
6.
What's 2 factorial?
2.
This is the number of unique distinguishable permutations, which is what I had here. 1, 2, 3.
Is it also the topic?
Fácil.
I'm not sure.
I have n.
We're gonna learn that in section 10.2.
Mister, why is it 3 plus 2 equals 6?
3 times 2 times 1. I recorded the video on Monday of our class like this, and I think I uploaded it to YouTube, but I went to sleep. I don't know if it actually uploaded, but I'll put it on Google Classroom. Okay, so this is an example. I'll do A and you guys can do B. Yes.
How did you
Raul, keep it down.
How did you get the S?
So S is for each of the letters that is repeated, you just write how many times it repeats. So S1 is the first letter that's repeated a lot of times. How many times is it repeated? In this case, it's 2, right? 1, 2. So you do 2 factorial. If there are more letters that are repeated, like for example in Miami, then I would have to do, like, count it for each of the letters that are repeated. I have to do that factorial in the bottom. Let me. Yeah. I'll do A, and then you guys can do B. So A. Okay. Now, if I had asked you yesterday, how many permutations does Miami have? What would you have said? You just count 1, 2, 3, 4, 5, and it's 5 factorial, not 5 factorial. Which would be 120 combinations. The issue is, if I grab this Miami and then I just switch these two I's, it's going to be the same word, right? Like these two I's are indistinguishable from each other, and so that I don't want to double count that word. And so what you have to do is use the equation that I just taught you, and you will get n factorial, where n is the total number of elements, in this case 5. So 5 factorial, that 120, we're going to divide it by some stuff. What do we divide it by? We count the number of times that the repeated letters, how many times it's repeated.
2.
For example, my m is repeated twice, right? I have 2 m's. So I would have to multiply by 2 factorial. But also, my I is repeated, so I have to multiply this 2 factorial by another 2 factorial. Because this 2 factorial represents the 2 m's, and this 2 factorial represents the 2 i's. So for every single element that's repeated, you have to do this factorial thing. 5 factorial is 120. And then 2 factorial is just 2, so 2 times 2 is 4. And so the total number of distinguishable permutations that I have is 30. Make sense? Try Tallahassee. It's a lot, but it's the same thing. You can use your calculator. You don't have to do it. The issue is that I think this is 11 factorial, and I don't think you'll do that in your head.
No, lo hizo aquí ya. Pura más.
And B, we can simplify, right? Because of really, really big number.
Sorry?
In B, we can't simplify.
What do you mean by simplify?
Like in A. No, wait.
You just have to put it into your calculator. So in your calculator, you would do like 5 factorial divided by, and then start a parentheses, divided by parentheses, and then 2 factorial times 2 factorial, close parentheses, and that'll give you an answer. Don't forget the parentheses, because otherwise it's going to think that you want to divide 5 factorial divided by 2 factorial and then multiply by 2 factorial. That's not what you want. In your calculator, you have to specify parentheses. If you don't specify parentheses,
Yes.
parentheses here, in your denominator. If you don't add the parentheses, it's going to think that you want to divide 5 factorial divided by 2 factorial, and then that answer multiply by 2 factorial. That's what it's going to think. Max, what did you get?
I got 30.
Do the formula and everything.
I got Tallahassee, so it's there are 11 letters.
Okay.
So there is 11 factorial
11 factorial in the top, because that's just the total number of elements.
divided by, there's 3 A's, so 3 factorial times
3 A's, 3 factorial.
times 2. There are 2 L, so there are 2 factorial. 2 factorial times 2 factorial SS.
So the S's also contribute another 2 factorial.
E is 2 factorial.
Okay.
And that's all.
Right? And when you put that into your calculator, what did you get?
48.
48.
131,600.
Yeah.
600.
No.
When you divide 11 factorial by whatever this is, so this is 6 times 2 times 2 times 2.
48.
So 11 factorial is a huge number, and when you divide it by 48, you get this number. Why are you confused?
Is it a
I thought I
3
had
times 2 6 times 2 12 times 24?
No. 3 factorial. 3 factorial is 6.
Ah, ok. ¿Por qué no lo simplificamos?
No multiplicas 3 factorial por 2 factorial. No multiplicas.
Ah, pues que si lo simplificamos está más fácil.
¿A qué te refieres con simplificar? If you didn't get this answer, then it's not easier, it's just wrong. This is the only correct answer. If you got something else, it's wrong.
No, lo que te pasa que no era que multiplicaras el número con todo y el factorial. O sea, que si fueras sumando 3 times 2 factorial, o sea, 3 factorial times 2 factorial gives you 6 factorial. Eso no lo que
No, you can't do that. You can't do that because 3 factorial is 3 times 2 times 1, right? And then 2 factorial is 2 times 1. So that's not the same as 6 factorial. Or,
no lo había simplificado. ¿Te salió esto? ¿Qué? ¿Me entiendes? No. Pero tienes que yo así sale eso. You don't have to actually do all of that. Son dos. Son 3 2. You don't actually have to multiply. You just so you'll do 11 factorial divided by 3 factorial, 2 factorial. Keep it down.
Contra el Thunder. Ay. Quedó 2-2 la ida.
Okay, try these three.
Dijo que le empaté al Madrid.
Yes. Factorial. Oh, I don't think you have it on that calculator.
Que sí, pirata tu calculadora, güey.
La compré en la papelería. Ah, no, la mía.
Google it later. Google it later. Did you Google it? Just Google the model number and see if it tells you how to do it. Maybe there's like a menu somewhere. I don't know. The scientific ones that have factorial and everything cost like $20.
Wait,
what?
Sí, están en la Walmart.
So cheap.
Y ahí dice para algebra 2, have trigonometry, ahí dice. La tuya fue donde costó, Chema.
Estaba en mi casa.
Guys, we're recording the video and it's really loud when you're talking.
Y escribí mal Cincinnati.
Isabella, number 8.
Por 10, ¿verdad?
So the word is mal, and I want to find all of the distinguishable permutations of the word mal. What's my equation?
4 factorial
Factorial,
over 2 factorial.
right? 4 factorial because I have 4 letters, and 2 factorial because L is repeated twice. 4 factorial is 24, 2 factorial is just 2, so this is 12. Okay? Paloma, number 9.
5 factorial.
Right? 5 letters, 5 factorial,
2 factorial.
2 factorial for the K or for the A,
And 2 times 2 factorial.
and then 2 factorial for the other letter. So 2 factorial for K, 2 factorial for A. What does that give you?
120 over 4.
Okay. And then number 10, Cincinnati.
Is that a real word?
It's a city.
I didn't know.
Yeah, it's a
Is it in Italy?
No, it's in the US. It's in Ohio.
Cincinnati, Bengals.
Okay. Joel, the new city that you just learned about. The new city that you just learned about. How do you calculate the number of distinguishable permutations?
7 factorial
10 factorial?
over 2 factorial, 3 factorial, and 3 factorial.
So 2 is for the C's, and then 3 is for the I's, and then 3 again for the N's, and I think that's it.
That's it. Yes. Then you just divide it. You find you multiply the factorials. The result of the factorials that is 72.
Okay?
Then you divide it by the factorial of 10, and it gives you 50,400. Yeah, give me.
What am I doing wrong?
What number did you get? A really big one? Did you get a really big number?
3,600,000.
So maybe the issue was that you didn't do the factorials. You just did 2 times 3 times 3 instead of doing 2 times 6 times 6. Because some other people, including other people made that mistake, and then somebody asked me, and then when I checked, I was like, oh yeah, you're right. And then they're like, nope, not right.
Es que puse
I made the same mistake. I forgot the factorials.
Puse 2 factorial. Puse 2 de 2 factorial y 1 de 3.
Okay, so the book has these types of questions where you're kind of playing like the teacher. So this is the question, and this is what the student wrote, and you have to figure out what did the students do wrong. So don't say it out loud, just think so that other people can figure it out as well. But what did this was the answer that the student wrote, and you have to figure out why is it wrong and correct it. Don't say it out loud, just think about it. First read the word problems and then correct the mistake.
Look.
Okay, Almejo, did you read the question already?
I know what's wrong.
Can you describe the situation that they're describing? What's the situation? The word problem. Before we go into the answer.
What are the different scenarios in which the first 4 numbers le sale lo que quiso? He got what he wanted.
Well, how many different ways can I pick for bingo balls out of 75, right? But what's the key thing that they said in the question? So what's the key thing?
Without being
One.
replaced.
That is the 1 to 75
Uh-huh.
that are not repeated, I think.
Right? The 75 balls are all unique because they all have one number from 1 to 75.
If you use one, you don't have it in the next option.
Exactly.
Which
So
is 75 pick 4.
right. And so the issue here is this is saying that whenever the balls are drawn from the container, they're not being replaced. So as soon as you already pick out a ball, you don't put it back in the container. You don't put it back in the container. And so this, what they did over here, that would be the scenario where you always put the ball back after you pick it. You just do 75, 75, 75, and 75. But
it would be 75, 74, 73, 72.
let's do the fundamental counting principle. It's the same thing. But let's use the fundamental counting principle. We're going to pick four bingo balls, right? So I have 4 little boxes where I can put my 4 choices. How many different bingo balls can I choose from for the first one? But because I'm not putting it back in the container, how many are available here? 74, 73, and 72. And so the issue is that the number of different ways that I can pick 4 bingo balls from a container of 75 when I'm not replacing this is 75 times 74 times 73 times 72 using the fundamental counting principle. But here they just wrote 75, 75, 75, 75. So this answer would be correct if we were replacing the balls. If every time that we picked one we put it back in, then in that case, yes, it would be 75 squared to the 4th power. And that's what was wrong. Now, remember, this was basically 75 pick 4, right? This was 75 pick 4, but I told you that the answer is this. What does that mean? 75 pick 4, which was 75 factorial divided by 75 minus 4 factorial. This is exactly the same as this. They're exactly the same, right?
But it doesn't work in the calculator, so.
This one does.
No.
This one you would have to do manually.
No, but 75 factorial divided by 70.
Oh yeah, 75 factorial. My calculator doesn't go that far to 75 factorial. So you can use the button or you can do this.
No, pues sí.
Sorry? Okay. So the question was, why is the answer not just 75 factorial? Because we're only picking 4. We're only picking 4 out of all of my 75 options. If I just asked you, how many different ways can I rearrange all 75 bingo balls, all of them, then it would just be 75 factorial. But because I'm only picking 4 out of the 75, I have to use this equation.
No, I mean how come it's not,
Well, so this is describing the number of options that I have for the first ball. So when I start the game, how many possible balls are there for me to pick from? So that's where this 75 comes from. Just 75, because that's the number of balls that I have to pick from. In the next round, I only have 74 balls left. So for my second ball that I bring out, I only have 74 options. Right? Remember the whole were you here on Monday? Okay, the whole example with the snowboard and the boots. Right? You had 3 choices for your snowboard and 2 choices for your boots, so on and so forth. That's what I'm doing here. Right? And this one, whenever I quiz you on this, more than half of the problems will just be word problems. Because these are they're not just gonna ask you for you to memorize. But not tomorrow, not the quiz tomorrow. It's on Google Classroom.
¿Qué cosa?
The quiz, what it's on.
¿Qué chapter es? Vamos, ¿qué chapter es?
Guys, do this, one more problem. One more problem.
Let's go out. Ya lo hice.
Lo hice al principio de la clase. No había cambiado la diapositiva. Y creí que era con el warm-up.
Es lo mismo.
What I'm trying to get you guys to get good at is interpreting the word problems. It does, like, this will not help you unless you understand how to apply it. You can do it this way too. If you don't remember this formula, you can do it this way. How many different people can I choose for the first position? How many different people can I choose for the second?
¿Qué te digo?
Yo, mister.
Espérate, apenas lo estoy apuntando.
No tienes que apuntar la pregunta, Nayo.
Pero es que luego no puedo estudiar bien porque luego no.
Pero lo buscas en los slides. ¿Cómo te complica la vida?
Mister, yo estoy intentando un nuevo método.
De no tomar notas.
Es que siento que si tomo notas, no me concentro en aprender.
No, el examen es
Y si dejo de tomar notas totalmente, lo puedo comprender mejor. Porque no me centro en otra cosa.
I would suggest if you do that, which is fine, when you study for the quiz or when you review, take notes so that you have like notes for your quiz.
¿Qué te dio?
But if I only use my
Raúl, sit down.
but if I only use like my mind, I will understand better, and in the quiz I will have my notes.
Right. But you have to write your notes at some point.
Yeah.
Well, where are your notes? You're not writing them. If you never write them, you don't have in your head.
Ahí te pasaste.
So if you study later, if you review, you can just write down notes like formulas and stuff, and you'll know how to apply them.
nomás con la pura fórmula, con eso la antes.
¿Por qué lo hiciste de esta manera?
Fuentes.
Y no me replicaste al padre.
Fuentes. How do I do this?
Yo, mister, yo.
Fuentes. I already called fuentes. Guys, keep it down.
Pones 9 factorial.
Ajá. Okay. 9 factorial.
And then abajo sería 3 factorial.
Well, so the question is 9 pick 3, right?
Ajá.
And my formula for 9 pick 3 is what? What's my formula?
N menos.
Do you have it written down on your notes somewhere?
N factorial divided by n minus 5.
So in this case, it would be 9 factorial on the top divided by
9 factorial, not 9, minus 3 factorial.
and so this is 9 factorial divided by 6 factorial, which is the same thing as 9 times 8 times 7, which is equal to what is it?
Is it wrong to put the 3 first? Like,
Sorry?
Is it wrong to put the 3 first?
Yeah, it's wrong because then if you put the guys, you're so loud. You're so loud. If you put the 3 first, the first number is the one that goes on the top, so you might get confused about which number goes where. So just the bigger number always goes in the front, and then the smaller number goes in, afterwards.
Thank you.
Yes.
Can you give us that base problem? ¿Cómo se dice los dos?